6.6 will cover parallel and perpendicular lines and their equations. So if we remember, we have to recall what a parallel line is. A parallel lines are lines in the same plane that intersect, forgot a really important word there, that don't intersect. So they don't cross one another, but they do have to be in the same plane. You'll learn more about that in geometry as opposed to Algebra 1 as far as a parallel line or not. A few little things that means is the following. Because there are lines that don't intersect, vertical lines are always parallel. Okay, and the reason that's going to be important is because if you remember, we'll go ahead and look at them here in just a minute, but you can't find their slope on vertical lines. Okay, so with that said, example number 1 says determine whether lines are parallel. Well, up here, in order for them to be parallel, if they don't intersect, that means their slopes are the same. Their B, though, has to be different. Because if everything was the same, they'd be the same line and everything would intersect. Okay, so again on this vertical line, remember vertical lines are lines where it is a x equals a number. So x equals 2. Okay, so if we draw that, a little sketch over here, x equals 2, it would be like this. Well, their slopes here are undefined. We can't find their slopes, so we can't really compare them other than to say that both slopes are undefined so that they are parallel. Okay, so that's just something to keep in mind. Are the graphs of y equals 1/3 x plus 5 and 2x plus 6y equal to 12 parallel? And explain. Well, in order to tell, you have to find the m and b. The form that will give you that the quickest is to put them in y equals mx plus b form. We're lucky because this first one is given to us in the correct form. Now we need to change the second one and get y by itself. So I'm going to subtract 2x from both sides. I end up with 6y equals negative 2x plus 12. I'm going to divide everything by 6. And I end up with the equation y equals negative 1/3 x plus 2. So there are my two equations I'm comparing. So in order to check to see if they are parallel, you check with the slopes. Are the slopes the same? And in this case, the slopes are not the same. Oh, this actually does say a negative 1/3. That's very hard to see. I'm sorry about that. That is a negative 1/3. If you look, it's barely separated. On here, on your paper, it shows up a little bit better. So over here, I'm going to put m is equal to negative 1/3 for both of them. Well, then I have to check the b's. Are they the same or are they different? My first b here is 5. The second b here is 2. So those are different. So the question was, are the graphs parallel, and explain. So are the graphs parallel here? Yes, they are parallel. And the reason they are parallel is because they have the same slopes. And different y-intercepts. And both have to be true in order for them to be parallel. Example number 2 then asks you to write an equation for the line that contains 5, 1 and is parallel to this. Okay, well, if we know that it contains this point, this is your x and y. If it's parallel to this, the only thing that can be the same is your m. So that's the only part I care about. I don't care about the rest of it. And it says write the equation. Again, it does not tell you what form to write the equation in. So you can write it in any form. I have a point, I have the slope. The fastest way that's going to be to write it is point slope form. Y minus 1 is equal to the slope x minus 5. And there we go. We're done. So that makes it very quick now that we know all three methods. The next part of this is going to be perpendicular lines. Okay, we have to remember the definition first of perpendicular lines. Perpendicular lines are lines that intersect to form right angles. Okay, and there's something special about their slope. So this time, when we said that slopes of parallel lines have the same slope, perpendicular lines, their slopes are opposite reciprocals. So for instance, if I have a slope of 1/2, in order for it to be perpendicular, and perpendicular is the upside down capital T is its symbol. To be perpendicular, the second slope would have to be opposite. This one was positive, so this one's going to be negative. And the reciprocal, so the reciprocal of 1/2 is 2/1. So my slope on my second line would have to be -2. So that would be how they signify whether they are perpendicular or not. Opposite signs, and then the reciprocal of one another for the slope. So example 3 says to write the equation for perpendicular lines. So if I look here, I have a point, and it's perpendicular to here. Again, the only thing we care about is its slope. And it's going to be perpendicular to it. So my first slope is equal to 5. Well, if I want one that is perpendicular to that, my second slope would be the opposite, so -5. The inverse would be 1/5. So my inverse there would be -1/5 as my slope. We could use point slope form again if we wanted to, because I do have a point. But I could also, if I recognize, since x is 0, this also gives me my b or my y-intercept. So I could very easily write it in the form y equals m x plus b, which is -2. So I could very easily write it as that form. It didn't say what form, so if you wanted to, you could use your point. Y minus a -2 is equal to slope times the quantity x minus 0. Well, you would want to simplify this. X minus 0 doesn't need to be written, so it would simply be y plus 2 is equal to -1/5 x. And again, that would mean the same thing because it does not tell you what form to write it in. Example number 4 then is the real world problem solving. A bike path for the new city park will connect the park to entrance to Park Road. The path will be perpendicular to Park Road. Write an equation for the line representing the bike path. Well, we know our bike path is going to go through this point, the park entrance, because that's where it's coming from. We run it to run perpendicularly to Park Road. Well, if it runs perpendicularly to Park Road, I know I need to find the slope of Park Road and use the opposite reciprocal. Park Road, I need to find 2 points on it. Here's an exact point, and here's an exact point. So to find my slope, I go up 2/1. So my slope is 2. So my line that is perpendicular to it would have a slope that is opposite it. The reciprocal then would be -1/2. So that's my slope. I do have a point it goes through. That point is 0,4. Because that's the y-intercept, I'm going to use the form y equals mx plus b. So y equals mx plus b in this case, which is 4. Write an equation for the line representing the bike path. We have it done. Go ahead and look at your schedule to find out what your assignment is to match with this section.